So we'll start with an exercise related to planning experiment. So planning experiment question. When you're planning experiment, especially for chemistry, you can write the paragraph or you can write the bullet points as well. An aqueous solution of a barium hydroxide is an alkaline. So when barium hydroxide is dissolved in water, it will form an alkaline solution. We have to plan an investigation to find the concentration of aqueous barium hydroxide solution. Like what is the concentration of this solution? How we can work out the concentration? Concentration is moles divided by volume. You're provided with an aqueous solution of a barium hydroxide, dilute hydrochloric acid of a known concentration, and we have the common lab apparatus. Here we have to specifically determine the concentration, because like if the question was how you can determine which two solution of a barium hydroxide are more concentrated, then we can compare the volumes. But here specifically we need the concentration, like what is the actual concentration of a barium hydroxide. So when a barium hydroxide reacted with a hydrochloric acid, so as a result it will produce a barium chloride, and acid plus alkali gives salt and water, so it will produce a barium chloride salt will be there because it's a hydrochloric acid. So as a result, this will be a barium chloride salt and water H2O will be there. But equation must be balanced. So BaOH plus 2HCl gives BaCl2 plus H2O. So it should be 2H2O as the equation is balanced. Now, so first, what we will do? We will, example, take 25 cm cube of barium hydroxide and transfer into conical flask. How we can transfer this 25 cm cube of a barium hydroxide into a conical flask? So which apparatus can we use here? By the help of pipette. You can mention measuring cylinder, but the barium hydroxide, it's alkaline, aqueous barium hydroxide is there. So we have a solution. So solution is there. That's why we will use a pipette, because it's written aqueous. Aqueous means like it is dissolved. So first what we did, we take 25 cm cube of a barium hydroxide and we transfer that into a conical flask, and we transfer that by the help of a pipette. Then we'll add drops of indicator. You should always name the indicator. You cannot just say add indicator. You can mention add methyl orange, add phenolphthalein. But universal indicator are not used for the titration purpose. The reason is that because universal indicator shows a color transition. That's why we will mention add, like example, drops of phenolphthalein, or we add drops of methyl orange. Originally, we have an alkaline solution. What will be the color of methyl orange? What will be the color of the methyl orange in alkaline solution? As we have a conical flask, and the conical flask is filled with a barium hydroxide, which is alkaline. So methyl orange is yellow. Methyl orange in alkaline solution, so you will mention yellow. When the solution becomes neutral, it will be orange. So add drops of methyl orange. You have to learn the color for indicators. So add drops of methyl orange. And how we can add that? By the help of, or by using dropper, or you can also say a teeth pipette. So we add drops of methyl orange by using a dropper or a teeth pipette. Then we will fill the burette with hydrochloric acid. So a burette is there. that is filled with a hydrochloric acid. So HCl is there in a burette. Then what we will do, we will add acid from the burette until indicators show a color change. So we will add acid from the burette until the indicator shows a color change. Then whenever you're doing the experiment, one-time experiment may not be accurate. So what we will do, we will repeat the procedure, or we'll repeat the experiment until we have a two concordant readings, or until the readings are concordant to 0.2. So we will repeat until the readings are concordant to 0.2. Like the difference between the two values is plus minus 0.2, either 0.2 more or 0.2 less. That time we will stop. Then how we can determine, now we know like what volume of acid is used. So using the volume and concentration of acid, we will find the moles of acid. That is the first thing, the hydrochloric acid. And then by using the moles of acid and the mole ratio, we will find the moles of barium hydroxide. Yeah, actually what we want the concentration of a barium hydroxide. So how we can determine the concentration of a barium hydroxide? So first what we did, we have the known concentration of a hydrochloric acid and we multiply by the volume, which we use for the titration. We'll get the moles of HCl. From the moles of HCl, we'll determine the moles of barium hydroxide. And from moles of barium hydroxide, like after knowing the moles of barium hydroxide, what will the concentration of a barium hydroxide? So concentration of barium hydroxide will be moles divided by volume. And moles were like n moles were there, and the volume which we used, like we took 25 cm cube. So it will be the total moles which are reacted divided by volume, will get the concentration of this barium hydroxide. Is it clear, this experiment, how we can determine the concentration of barium hydroxide by using